Section 7.4 is on parallel lines and proportional parts. The triangle proportionality theorem says that if a line is parallel to one side of a triangle and intersects the other two sides, then it divides the sides into segments of proportional lengths. So in other words, given triangle ACE, okay, if we have segment BD, which is parallel to side AE, then CB over BA is equal to CD over DE. So in other words, I don't have to say, basically I'm comparing the two triangles, but I don't have to say CB and CA. I can just say CB over BA is equal to CD over DE. Another way you can do this is you can actually kind of go across the triangle. I could say CB over CD is equal to BA over DE. It doesn't matter which way you go. So as long as you're kind of staying on the same side, not doing any strange cross sort of thing. So top left over bottom left equals top right over bottom right, or top left over top right equals bottom left over bottom right. The converse is also true. If any of those sides are proportional, then we know that BD, segment BD, is parallel to segment AE. So using that, let's go ahead here and find x. So there's actually a couple different ways I could set this up. I can say 3 over 8 equals x over 12. So top over bottom equals top over bottom. Or I could say top over top equals bottom over bottom. 3 over x equals 8 over 12. You can't do anything that goes across. You can't use like 3 over 12 and x over 8. So let's go ahead and do this. So 8x is equal to 36, which gives me x is equal to 4.5. And notice when I do the multiplication over here, I'm going to get the same cross product. So it doesn't matter which way you set it up. Top over bottom equals top over bottom. Top over top equals bottom over bottom. So x is 4.5. Okay, here's another example, similar picture. CD is equal to 1/2 of DA, and they're asking us, is DE parallel to AB? In other words, are the corresponding sides here proportional to each other? Okay, so if CD is equal to 1/2 of DA, notice I don't have any markings over here, but I think I can actually add something. CD is 1/2 of DA, so if I call CD X, DA is twice as long as that. CD is 1/2 of DA. So DA I can call 2x, CD I can call x. So let's set up a proportion and see if the corresponding parts are proportional to each other. So I can say x over 2x, is that equal to 18 over 36? I could also say, is 18 over x equal to 2x over 36? Same idea. So solving the cross products here, 36x is equal to 2x times 18. So 36x is equal to 36x. Now, this may bother you because I can't figure out what x is, but it doesn't matter what x is, because indeed the sides are going to be proportional to each other. So, yes, so since CD over DA is equal to CE over EB, then DE is parallel to segment BA because the corresponding parts are proportional to each other. The midsegment of a triangle. Remember we had the midsegment of a trapezoid in the last chapter. Here we have the midsegment of a triangle. And again, it's going to be just like in a trapezoid. It's a segment whose endpoints are the midpoints of the sides of a triangle. So let's take a look at this picture here, and I know I have a lot of little marks in here. But here we have triangle ABC. Let's look at big triangle ABC. And DE is considered a midsegment of the large triangle because D is the midpoint of AC, and E is the midpoint of BC. So DE is considered a midsegment. Notice that DF is also a midsegment because D is the midpoint of this side, F is the midpoint of AB. Segment EF is also a midsegment because E is the midpoint of CB, and F is the midpoint of AB. So every triangle actually has three midsegments. Basically, just find the three midpoints of the sides and then draw those lines, and that's going to give you the midsegments. The triangle midsegment theorem says that the midsegment of a triangle is parallel to one side of a triangle, and its length is 1/2 of the length of that side. So, in triangle, again, triangle ABC, and this side I only drew one midsegment here. If DE is a midsegment of triangle ABC, then DE is parallel to AB, and the length of DE is 1/2 the length of AB. So if AB were 10, DE would be 5. If AB were 20, DE would be 10. If DE is 6, AB is 12. Okay? And they are parallel to each other. Actually, you know what? I think I'm going to add some pictures, some little marks here to show that this is indeed a midsegment. There we go. D is the midpoint of AC, and E is the midpoint of BC. I like that better. So here's an example. So we have big triangle ABC, and we have a couple lines drawn in there. So DE is a midsegment, and EF is a midsegment. And notice, thank goodness we didn't draw the third one, which would be FD probably. So we need to find the length of AB, the length of FE, and the measure of angle AFE. Well, if DE is a midsegment, okay, that's going to be parallel to AB, and DE is going to be 1/2 of the length of EAB. So DE, I'll do it down here, so DE is going to be 1/2 the length of AB, and DE is 5, is 1/2 of AB, so multiplying both sides by 2, AB is going to be 10 units long. Okay, same idea here. Now we have EF is also a midsegment. EF is going to be parallel to BC, and EF is going to be 1/2 of BC. I don't know what EF is, so I'll just leave it EF, but I do know that BC is 18, so the length of EF is going to be 9 units. Okay, so I have those two. Now I need to find the measure of angle AFE, and I'm going to go ahead and mark that. AFE is this angle right here. Okay. Well, if ED is a midsegment, then I know that AB is parallel to DE, and what I basically have is parallel lines, and this right here is going to be my transversal. Okay, so let me write some of this out. So I have that AB is parallel to ED, okay, and EF is my transversal, so that means that angle AFE and angle, the one I have a measure for here, FED, are alternate interior angles. Okay, and if we have parallel lines cut by a transversal, alternate interior angles are congruent. Therefore, the measure of angle AFE is also going to be 87, the same as angle FED. Maybe I should box that. There we go. Okay, corollary here that kind of remember, a corollary is just a little statement that kind of follows from a theorem. So the proportional parts of parallel lines corollary says if 3 or more parallel lines intersect 2 transversals, then they cut off the transversals proportionally. So here we have 3 parallel lines, and you can actually have more than that, and we have 2 transversals. Then all of those little parts are going to be proportional to each other. Okay? If AF is parallel to BE, which is parallel to CD, then AB over BC is equal to FE over ED. In other words, the parts that are cut off, the parts of the transversal that are cut by the parallel lines, are proportional to each other. AB over BC equals FE over ED, and you can also say AB over FE is equal to BC over ED. Next corollary is the congruent parts of parallel lines corollary, and it says again, if 3 or more parallel lines are cut off congruent segments on one transversal, then they cut off congruent segments on every transversal. So we have 3 parallel lines, and we have a transversal over here. So if AB is congruent to BC, okay, so the parallel lines cut off congruent segments on one transversal, then they cut off the congruent segments on the other transversal. AB is not parallel to FE, but the 2 that are cut off over here are congruent to each other, as are the 2 over here that are cut off. So given that, let's find X. Or actually, this would refer back to the first one, because obviously the 2 pieces that are cut off are not proportional to each other. But I do have 3 parallel lines, 2 transversals, so I can say 13 over 26 is equal to 16 over X, since those correspond to each other. Or I could say 13 over 16 equals 26 over X. Either one of those is going to work. Let's see, doing that, actually I don't have this written out, so that's 13x equals 26 times 16 is 416, or x is equal to 32. And notice if I do the same thing over here, I'm going to end up with 13 times x is equal to 16 times 26. I actually get the same cross products. So x is equal to 32, and the cool thing is you can write this proportion 2 different ways. And our last example here, find x and y. So we have 3 parallel lines cut by 2 transversals, but notice that on this right-hand transversal, the parallel lines cut off congruent segments. So very obviously, 3x minus 7 is equal to x plus 5. But our second corollary said that if congruent parts are cut off on one transversal, then the other transversal is cut off into congruent parts. So that also means that 9y minus 2 is equal to 6y plus 4. So very straightforward. So 2x equals 12, x is equal to 6, 3y equals 6, y equals 2. Now I know in this section it seems like there's a lot of theorems, a lot of corollaries, a lot of confusing stuff. Actually, proportions, I say go with your gut. If it looks like, you do need to know a few basic ground rules, like what things are parallel to each other. But if the proportion makes sense, it's probably going to work. So for example, in this problem over here, 13 over 26 equals 16 over x, top over bottom equals top over bottom, or either top over top equals bottom over bottom. What is not going to work is when you kind of go across 13 over x and 16 over 26. That's just not going to work. So when you're setting up proportions, I would say go with what kind of seems to make sense.